Welcome to the 7th part of VCAA Math Method 2021 exam paper series. In this video, we will present exam paper 2, section B, question 1, which consists of 7 parts. Questions 1B, 1F, and 1G were scored poorly.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding, so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA exam paper series. This is section B of 2021 exam 2 paper. There are total 5 extended response questions in section B. In this video, I will present you the first question. As it can be seen from the diagram on the screen, the first question shows a rectangular sheet of cardboard which has a width of h centimeters. Its length is twice its width. Squares of side length x centimeters are cut from each of the corners. The sides of this sheet of cardboard are then folded up to make a rectangular box with an open top as shown in the diagram. Assume that the thickness of the cardboard is negligible in this question. Here we continue with section B, question 1. From the previous screen, now a box is to be made from a sheet of cardboard with h equals 25 cm. And based on this, there are 7 parts in this question. Part A is to show that the volume VBox in cubic centimeters is given by VBox equals 2x times 25 minus 2x, or in parentheses times 25 minus x, or in parentheses. Accordingly, part B is to find the domain of VBox. Part C is to find the derivative of VBox with respect to x. Part D is to calculate the maximum possible volume of the box and for which value of x this occurs. Part E is to calculate the percentage of the cardboard area wasted when x equals 5 cm due to the cutting off some of the sheet before making the box. Now consider a box made from a rectangular sheet of cardboard where h is greater than 0. The box length is still twice its width. Based on that, the first question of part F is to express VBox in terms of h as well as to state the domain of VBox. The second question of part F is to find the maximum volume of VBox for any such rectangular box in terms of h. Now consider making a box from a square sheet of cardboard with side lengths of h centimeters. Part G of this question is to show that the maximum volume of the box occurs when x equals h over 6. Since this is a long question, we need to look back what part A is asking for. Yeah, it is asking to show VBox equals 2x times 25 minus 2x, or in parentheses times 25 minus x, or in parentheses when h equals 25 centimeters. Since VBox equals length times width times height, it equals 2h minus 2x, or in parentheses times h minus 2x, or in parentheses times x, which equals 2x times 25 minus 2x, or in parentheses times 25 minus x, or in parentheses cm cubed when h equals 25 cm as required. Since part B is to find the domain of VBox and the length of the box x is greater than 0 but less than 25 over 2 due to 2x is less than 25. Hence the domain of VBox is within the open interval from 0 to 25 over 2. Part C is to find the derivative of VBox with respect to x. VBox can be written to 4x cubed minus 150x squared plus 1250x after expanding the factorizer form in part A. So the derivative of v box with respect to x equals 12x squared minus 300x plus 1250. Part D is to calculate the maximum value of v box and for which value of x it occurs. Since the derivative of v box has just been worked out, the stationary point can be found by setting the derivative of v box to 0. Hence, we have the quadratic equation 6x squared minus 150x plus 625 equals 0. The root or roots of these quadratics are the stationary point of v box where its maximum value occurs. To solve this quadratic equation, we check its discriminant first, which equals 150 squared minus 4 times 6 times 625 equals 3 times 50 squared. Accordingly, x equals 25 over 2 plus or minus 25 square root 3 over 6. Since x is between 0 and 25 over 2, x equals 25 times 3 minus square root 3 or in parentheses over 6. Hence, the maximum value of v box equals 15,625 times square root 3 over 9. When x equals 25 times 3 minus square root 3 or in parentheses over 6. Part E is to find the percentage of the cardboard that is wasted when x equals 5. According to the definition of waste, it is calculated by 4x squared divided by the product of 2h and h, which equals 8% after being calculated. If the length of the box is twice its width, part F is asking to state the domain of v box in terms of h and then find the maximum value of v box. Since v box equals 2x times h minus x or in parentheses times h minus 2x or in parentheses where x is within the open interval from 0 to h over 2. And since the derivative function of v box with respect to x equals 12x squared minus 12hx plus 2h squared, we set it to 0 and then find the value of x, which equals 3 plus or minus square root 3 or over 6. Due to x is between 0 and h over 2, as we said earlier, x equals 3 times square root of 3 or over 6. Hence, the maximum value of v box equals square root 3 over 9 cm cubed when x equals 3 minus square root 3 or over 6 centimeters. If a box is made from a square sheet of cardboard with side length of h cm, part G of this question is asking to show that the maximum volume of the box occurs when x equals h over 6. Based on the box is made from a square sheet of cardboard from our earlier formula, the volume of the box, v box, equals x times h minus 2x or in parentheses times h minus 2x or in parentheses, which is x times h minus 2x or in parentheses squared. Hence, the derivative function of the volume of the box, v box, with respect to x equals 2x minus h or in parentheses times 6x minus h or in parentheses. Due to x is less than h over 2, x equals h over 6. So, when x equals h over 6, the volume of the box, v box, reaches its maximum value, which equals h over 6 times h minus h over 3 or in parentheses squared, which equals 2 times h cubed over 27 centimeter cubed.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.